Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at how to use combinatorics and apply it to probability. So when a tree diagram is too complicated because it's so large to represent a solution, that is when we can use combinatorics because it can be used to determine the size of the sample space and the size of the event set. Now recall that when you're reading the question, decide whether it is a permutation question or a combination. Because for permutation, order is important. But for combination, order is not important. Now, the other important thing to note is for combinatorics to be used, it can only be used if an item is used once, meaning no replacement. So let's take a look at an example. Suppose 9 cars are entered in the Grand Prix and all are equally likely to win. What is the probability that one car, we'll call him Lightning McQueen, will finish in the top 3? So the probability of finishing in the top 3 is equal to the number of ways in which Lightning McQueen is in the top 3 divided by the total number of possibilities or total number of possible race finishes. All right, now before we go right into the format, let's take a look at each case. Now, in this example, there are 3 cases because Lightning McQueen can come first, second, or third. Now, if he comes first, that means that the other cars can be permutated because order is important. 8 factorial ways. If Lightning McQueen comes second, the other cars can be permutated still 8 factorial ways because they are going to be first, not second, but they'll be third, fourth, and so on. So this means that there are still 8 factorial ways. And if Lightning McQueen comes third, the other cars can still be permuted 8 factorial ways because there's still going to be a different car that's first, a different car that's second, he is third, and then there's fourth, fifth, sixth, all the way to ninth, and so on. So again, there are 8 factorial ways. Therefore, the probability that Lightning McQueen is in the top 3 is equal to 8 factorial plus 8 factorial plus 8 factorial, different ways that he can come in the top 3, and the total number of possible race finishes is 9 factorial because there are 9 different positions. We can then also think of this as 3 times 8 factorial divided by 9 factorial, and then this actually reduces to 3 times 8 factorial, and then 9 times 8 factorial. And the 8 factorials cross off, and 3 over 9 reduces to 1/3. Now we can also think of this as 3 times. So there are 3 positions for Lightning McQueen, and then 8p8, because the other 8 cars can choose 8 different positions, divided by 9p9, because there are a total of 9 positions and 9 to choose from. And that also will give us 1/3. Let's take a look at another example. So cribbage is a common game. It's played with a regular 52 card deck. So an advantageous crib hand contains many cards that total to 15 in different ways. So a hand that contains 5s is desirable. So my first question, you don't need to know anything about crib, but what is the probability of being dealt 4 5s in a crib hand of 6 cards? So I always like to write out what we're going to try to find in words first. So the probability of 4 5s is equal to the number of hands with 4 5s. And we're going to divide that by the total number of possible hands. All right, so that equals the number of cards with, number of hands with 4 5s. That means out of 4 5s, we want to choose 4 of them. Now, the reason that we're using combinations is it doesn't matter how you hold the cards in your hand, we still have those 4 5s. Now, we are wanting to have 6 cards. So we need to multiply that by 48 other cards, and we want to choose 2 of them. And then this is all divided by the total number of possible hands. So that means that there are 52 cards to choose from, and we want to choose 6 of them. So we just have to type this out onto our calculator. And 4C4 is 1. There's only one way to choose all 4 numbers. And 48C2 is 1128. And then all divided by, and there's a lot here, 20,358,520. And then this reduces to 3 over 54,145. Or if you want to change it to decimal, 0.0000554. So very, very unlikely that you're going to get all 4 5s. Let's take a look at the second question with the crib hand. So what is the probability of being dealt at least 1 5 in a crib hand of 6 cards? So the probability of at least 1 5. Now the easiest way to find this is actually going 1 minus the probability of no 5s. So we can go 1 minus. So out of the 4 5s, we want to choose 0 of them. And then we're going to multiply that by 48 cards, C6, because we want to choose 6 cards, none of them being 5s. And all of that is now divided, not all of that. The 1 minus, that's not a probability, that would be 100% minus. And then just the second part is going to be divided by 52 cards altogether, C6. So when you calculate all of this and type it into your calculator, you're going to get 0.3972, or you can also think of this as a probability by timesing by 100, and you're going to get 39.72%. All right, let's take a look at another example. So a pizza store offers 15 different toppings on its pizzas. What is the probability that 4 randomly selected toppings will include salami and green peppers? So in this example, we're going to assume that it doesn't matter what order the toppings are in. It doesn't matter if you pile salami on top of green peppers or green peppers on top of salami, although some of you might worry about that. Now, in this question, the salami and green peppers, we want those for sure. So we want the probability of salami and peppers. So that's going to equal 2C2. So there are 2 choices, salami and green peppers, and we want both of those choices. So 2C2 times, now we only have 13 toppings left because we've taken out 2 of them, C, and because we want 4 toppings altogether, then we want 2 of the other toppings. This is all divided by 15C4. Now, if you notice, these questions here, that the first numbers in front of the C will add up. So notice the 2 plus 13 in the numerator adds up to the 15 in the denominator for the number in front of C. Same as over here. So we have 4 plus 48, and that equals 52. Notice that the second number, the 2 and the 2, adds up to our second number where after the C. Same as in the question before. So 4 plus 2 is 6, which is the number in the denominator after the C. Okay? So kind of always keep that in the back of your mind so that you know that you haven't missed any of the values. So calculating this, using your calculator, you get 78 in the numerator and then 1365 in the denominator, which reduces to 2 over 35, or as a decimal, 0.0571 or 5.71%. All right, let's take a look at one more type of example. So 4 people are to be randomly selected from a group of 8 boys and 6 girls. Now remember, all of these people are different. What is the probability of each event? So exactly 3 people will be girls. All right, now order again doesn't matter. It doesn't say that we need them in any special order. So exactly 3 girls. So there are 6 girls to choose from. And I'm going to choose 3 of them. So 6C3 times, there are 8 boys to choose from. And because I want a group of 4 people, that means that I need 1 boy to make up that group. And that's going to be divided by 14, because there's 14 people altogether, C4. That's my total sample space. So no matter whether I have boys or girls, there are 14 people, and I'm going to choose 4 of them. So typing all of this out, we get 0.16. All right, let's do a couple more. So all 4 people will be boys this time. So the probability of 4 boys, so we want 8C4 because we want to choose all boys times, and just to make it consistent with the other questions, there are 6 girls and we don't want to choose any of them. So that's 6Z0 divided by 14C4. So again, if you notice in both of these questions, the numbers in front of C in the numerator add up to the numbers in the denominator in front of C, and then the number after C in the numerator adds up to the number after C in the denominator. So calculating this last one here, we get 0.070. All right, the last one here I wanted to show you because it's a little bit different. So the probability at least 3 girls. So to find that, that means that we want probability of getting 3 girls, but we also want the probability of 4 girls, because at least 3 means that we want 3 or 4. And remember, whenever we say or is adding. Now we already got this probably 3 girls from before, so I'm just going to rewrite this down by copying it from above. Okay, and then plus, this time we want 6C4. We want 6, out of 6 girls, we want to choose 4 of them, times 8C0. We don't want any boys. And then our denominator is 14C4. And then typing all of this out, we get 0.175. So that's how we apply and use combinatorics and probability to simplify our problem-solving process.